Hello all, hope you're doing well today. So today we are starting, it's chapter 6, part 1, and we're talking more about facility planning, construction, and building life cycle. So through this content in the chapter, really kind of expect for you to understand the importance of facility design principles as well as the level of architect inclusion in the planning and designing of the facility. Also important for you to comprehend the life cycle cost analysis process and the application of the life cycle assessments, and be able to analyze the facility space needs, including those ancillary spaces that we don't normally think about, and become familiar with the facility construction process in general. So here we go. Facility design and construction play a crucial role in maximizing the functional life of sports and recreational spaces. A well-designed facility ensures longevity, efficiency, and adaptability to the needs of its users. When planning a new sports facility, several key factors come into play. The geographic location, environmental impact, and the demographic characteristics all influence how the facility serves the community. Each new facility is specifically designed and constructed with its end users in mind, whether it's a local gym, a community sports center, or a large stadium. The goal is to meet the needs of athletes, spectators, and the stakeholders. Designing a sports facility goes beyond just construction. It's about creating an experience. A well-designed facility enhances functionality, reduces cost, and leaves a lasting impression on its users. So it's really important to create an attractive physical environment and sense of place. A great facility isn't just functional, it's inspiring. Thoughtful architecture and design create an environment that athletes and visitors enjoy being in, enhancing engagement and satisfaction. It's also important to look at reducing operational cost, and so efficiency matters. Strategic design choices such as energy efficient lighting and sustainable materials and smart technology help minimize long-term costs while maximizing performance. You also want to balance complexity with cost. So eye-catching designs with a wow factor can enhance the user experience, but they come at a price. Designers must balance aesthetics with budget constraints to create a sustainable facility. You want to foster pride and branding opportunities. A well-branded facility fosters team pride and community identity. So logos, colors, and architecture can reinforce a team's legacy and make the venue a recognizable landmark. You want to ensure functional and visual consistency. So every space should be both practical and visually appealing. Consistency in design helps create a cohesive experience for athletes, staff, and spectators. You want to provide clear guidance for facility designers. So guidelines help ensure that each facility meets the needs of its users, from seating arrangements to accessibility considerations. Every detail must be planned with purpose. Architecture is too important to be left to architects alone. A successful sports facility requires input from multiple stakeholders, ensuring that both functionality and aesthetics align with the institution's vision. So facility administrators and selected committee members must be actively involved throughout the process. Their insights help shape a venue that meets operational needs, enhances user experiences, and stays within the budget. So you have to select the right team. Not all architects are the same. Reviewing the qualifications of key design professionals is critical to ensuring the best fit for a project. Experience in sports facility design, understanding of compliance regulation, and a history of innovative solutions should all be considered. You want to utilize specialized consultants. A sports facility is more than just walls and seats. It's a complex system requiring expertise from multiple disciplines. Structural integrity, lighting, climate control, and environmental considerations all play a role in creating a high-performance venue. By engaging a diverse team of specialists, including space programmers, environmental consultants, and interior designers, facilities can achieve both efficiency and experience in design. Through a collaborative approach, institutions can create spaces that are not only visually stunning but also functional, sustainable, and future ready. And I feel like that our Dugan Wellness Center gym, as well as our Island Hall gym, kind of incorporate all of that into the design. They are visually appealing. We have our logo, of course, in Dugan Wellness Center, not necessarily in Island Hall gym, but that is a teaching facility versus more of a competition facility, as Dugan Wellness Center is. Heating, ventilation, and air conditioning, or HVAC systems, are critical components of any building's infrastructure, ensuring the comfort, air quality, and energy efficiency of the space. The system controls the environment inside a building by regulating temperature, humidity, airflow, and air quality. HVAC systems are particularly important in sports facilities where the comfort of the spectators, the athletes, and staff is a priority, as well as in energy-conscious design. Some components of the HVAC system are, of course, heating. And really, its purpose is to maintain the desired indoor temperature during cold weather. And ways of doing that are with furnaces. So gas, electric, or oil powered are common systems for heating air. Heat pumps can also be used for heating, which works by transferring heat from the outside air into the building. And radiant heat provides heat directly through heated floors or ceilings. We don't typically need a lot of heating just because we are in a hot environment. Ventilation is really important. It helps to ensure the flow of fresh air into the building, removing stale air and regulating humidity. Proper ventilation is vital to prevent the buildup of harmful gases or pollutants and maintain comfort. And they're finding that many diseases that we're passing around, especially in the winter, are caused from our ventilation system. So really is important. Methods of ventilation are utilizing windows and vents or louvers for air exchange without mechanical assistance. Now, mechanical ventilation includes fans, air handling units, or AHUs, or ventilation ducts to circulate fresh air and remove stale air. The exhaust systems remove pollutants or odors from specific areas like locker rooms or kitchens. And of course, the air conditioning, which is for cooling. It regulates the temperature in warmer weather and provides a comfortable environment. So ways of doing that are with central air conditioning. It uses large units to cool the air and distribute it throughout the building via ducts. You also have chillers, which are large air conditioning systems that cool water, which is then used to cool air through air handlers or cooling coils. And evaporative cooling, which is an energy efficient system that cools the air by evaporating water in low humidity climates. Now, design considerations for HVAC in sports facility really require temperature control, and so that your sports facilities requires precise temperature control to keep the environment comfortable for athletes, spectators, and staff. That involves selecting HVAC systems capable of adjusting quickly to changing needs, such as during events or practice sessions. And large arenas may need separate zones or HVAC systems for different areas like spectator areas, playing courts, locker rooms, to address the varying cooling and heating demands. The air quality, so fresh air supply is one method, and it's really important and an important aspect of ventilation, especially in facilities with large crowds. Introducing a sufficient amount of outdoor air helps to reduce CO2 buildup and provides fresh air. Air filtration, high efficiency particulate or HEPA filters can be used to remove dust, allergens, and other particles to improve air quality. And humidity control. Maintaining the correct humidity level is essential for the comfort of occupants and to preserve the integrity of sports surfaces. Too much moisture can lead to mold and mildew, while too little can cause dryness and irritation. And energy efficiency. Sports facilities, especially large arenas or stadiums, have high energy consumption due to the size and need for air conditioning and heating. Systems must be designed with energy efficiency in mind to reduce costs and meet environmental standards. There's a facility in town that it's large, and it just keeps getting bigger and bigger. And we were talking with them one day. They said their electric bill was $20,000 a month. Can you imagine? And you also need energy recovery ventilators, or REVs, and heat recovery ventilators, HRVs, that can help by exchanging heat or energy between exhaust and incoming air, thereby reducing the workload on your HVAC system. Implementing zoning can also help minimize energy waste by conditioning only occupied areas of the facility. Your control systems are typically your building management systems, or BMS, is a centralized control system that is used to monitor and control the HVAC systems across the facility. It can adjust temperatures, humidity levels, and airflow based on occupancy or time of day, improving comfort and energy use. And smart thermostats allow for automatic adjustments to the HVAC settings, optimizing energy consumption while maintaining comfort. Now, your HVAC system and sports venues must operate quietly to avoid disturbing events or causing discomfort to spectators and players. Sound dampening materials, vibration isolators, and proper system design can help reduce that noise level. In locker rooms or offices, careful selection of ventilation systems, fan types, and placement can help minimize noise as well. And due to the large and sometimes demanding environment, HVAC systems in sports facilities must be designed for durability and easy maintenance. Regular inspections and cleaning of filters, coils, and ducts are essential to maintain optimal function. You also want to look at energy efficient design strategies. So in some climates, using natural ventilation strategies like windows and vents can reduce reliance on mechanical HVAC systems. And solar energy systems or geothermal heating and cooling can be integrated to support HVAC systems and reduce energy use. Now, lighting in sports facility is essential for both functionality and atmosphere. It impacts the performance of athletes, safety for spectators, and energy efficiency. So proper lighting design ensures that the facility serves its intended purpose while also providing a pleasant environment. Different areas of the sports facility will require different types of lighting depending on the activities and needs of the users. So types of lighting in sports facility are general lighting, so providing overall illumination to spaces such as corridors, locker rooms, and seating areas, and can be provided by overhead fixtures like recessed lights or pendant lights or surface mounted fixtures. The level of general lighting should be consistent throughout common areas for safety and comfort. And then task lighting is provided focused light to specific areas where detailed tasks need to be performed, such as training rooms or kitchens or equipment storage areas. It can be accomplished through adjustable lamps or downlights. Accent lighting is used to highlight architectural features or certain areas of the venue, such as trophies, team banners, or VIP areas, and can create ambiance and enhance the aesthetic appeal of the facility. Now, sports-specific lighting for indoor sports specifically, it includes sports like basketball, volleyball, or indoor soccer, where focused, bright, and uniform light is needed to ensure good visibility for both the players and spectators. Outdoor sports includes lighting for stadiums, fields, or tracks, and the lighting here needs to provide ample brightness over large areas, often requiring high mast or pole-mounted fixtures to cover expansive spaces. And then you need emergency lighting, essential for safety during power outages or emergencies. It includes your exit signs, your emergency floodlights, and path lighting to ensure safety evacuation. Now, there are different areas of sport facility that require different lighting intensities. For example, the playing court or field needs to be brightly lit to ensure visibility, while concourses or lobbies may require lower or softer light. For competitive sports, there are specific illumination standards set by governing bodies like the Illuminating Engineering Society or FIFA. These standards ensure safe athletes have optimal visibility and the safety of spectators is maintained. The lux or LX is the unit of measurement for lighting levels. For example, a professional basketball court may require illumination of around 100 lux, while seating areas for spectators might only need 200 to 500 lux. You also need uniformity of lighting, and this refers to how evenly the light is distributed throughout the space. And sports facilities uniform lighting is crucial, especially on the playing field or court, as uneven lighting can create shadows or glare, affecting performance and safety. The uniformity ratio is typically specified as the ratio between the highest and lowest light levels on the playing surface. A lower ratio indicates better uniformity. And then glare control. Glare can impair both athletes and spectators' vision. This is especially important in areas like courts or fields with overhead lighting. Your fixtures should be positioned and shielded to minimize direct light into the eyes of players and spectators, especially in areas like the stands or during broadcast events. And the ability of a light source to reveal the true colors of objects is essential for sports facility, especially for televised events. So the color rendering index, or CRI, measures how well light sources render colors compared to natural light. Your high CRI lighting, typically above 80, is preferred for indoor sports to ensure accurate color reproduction both for the participants and the audience. And sports facilities use significant amounts of energy for lighting, especially in large arenas or stadiums. Therefore, energy efficient lighting systems should be prioritized. LED, or light emitting diode technology, is commonly used in modern sports facility because it consumes less energy, has a longer lifespan, and provides instant brightness without the flicker associated with older technologies like the fluorescent bulb. And again, sport control systems. So your lighting control systems can optimize energy consumption and provide flexibility in lighting configurations. There are dimming systems and motion sensors and automated controls that can adjust lighting based on the time of day, occupancy, or even the type of event being held. These systems can allow for changing the lighting ambiance for different events, bright lights for a game, or soft colored lights for a concert. Lighting for broadcast and media. So again, you have to meet specific standards for televised events, particularly to ensure clarity and high quality images. Professional sports events needs high intensity lighting that provides clear visibility on camera and prevents flicker. Additionally, the lights should be designed to avoid any reflections or shadows that may interfere with the broadcast. And given the high traffic in sports facilities, lighting systems should be durable and require minimal maintenance. Lights should be clean, easy to clean, and positioned for easy replacement or repair if necessary, especially in large venues with high ceilings. Now, again, for standards, the indoor sports courts and fields, your basketball courts, 500 to 1,000 lux at the playing field. Volleyball courts, 300 to 500 lux at the playing surface. And indoor soccer fields is 500 to 1,000 lux at the playing surface. For outdoor soccer and baseball fields, it's 500 for minimum for training. But it goes up with your professional lux, or to 1,000 to 1,500 for your professional games. And your spectator areas, again, a minimum of 200 and up to about 500 for high traffic areas. Now we're going to talk a little bit more about the life cycle planning and cost analysis. Every sports facility has a lifespan, and effective life cycle planning ensures it remains functional, cost efficient, and adaptable over time. This process establishes the full anticipated cost of a structure, product, or component throughout its useful life. There are 5 stages of facility life cycle planning. The first of those is the pre-construction planning. This is before breaking ground. Extensive planning is essential. This stage includes feasibility studies, budgeting, site selection, and long-term financial projections to ensure a strong foundation for the facility's success. The second stage is equipment and building component selection. So here, choosing the right materials and equipment will impact performance, maintenance costs, and sustainability. Smart investments in durable and energy efficient components reduce long-term expenses. The third stage is potential renovations, repairs, and equipment replacement. As facilities age, updates are necessary to maintain safety and appeal. Renovations, structural repairs, and technology upgrades keep the venue competitive, and functional. And then the changing desires of the community and deterioration. So community needs evolve over time, whether it's adding new training facilities, expanding seating, or integrating smart technology. A facility must adapt to remain relevant and useful. And eventually you do get to the end stage of the facility. Every facility will eventually reach the end of its useful life. And at this stage, decisions must be made about repurposing, reconstruction, or complete redevelopment to meet future demands. You probably have seen our field house on campus, and at one time it was our only facility for sports until the Dugan Wellness Center was built and Island Hall Gym. And it has been repurposed to be more of a training center for our athletes. And it will be interesting to see how long it lasts in that stage. While the initial construction cost of a sports facility is significant, it's only a fraction of the total expense over its lifetime. Studies estimate that operation and maintenance costs far exceed the initial investment. This is where life cycle cost analysis, or LCCA, becomes essential. And if we break down those life cycle costs into a formula, it looks like this. So LCC is that total life cycle cost and present value dollars of a given alternative. I is for the initial cost. So if it's 50 million, that would be your initial cost. And then the replacement value, again, looking at present value, capital replacement costs. And then looking at the residual value or resale value minus disposal cost. And then energy, what is the total energy cost, again in present value. And water, what are your total water costs? And then if you look at operating, maintenance, and repair, what are the total operating, maintenance, and repair costs? And any other costs. So contract administration costs, financing, employee salaries and benefits, so forth. When designing and operating a facility, it's essential to consider not just the financial cost, but also the environmental impact. This is where the life cycle assessment, or LCA, comes into play. And it's defined as a compilation and evaluation of the inputs, outputs, and the potential environmental impacts of a product system throughout its life cycle. It provides a holistic approach to understanding the long-term sustainability of a structure, product, or process. Now, in evaluating environmental costs, you're measuring the ecological footprint of a facility, including its carbon emissions, water consumption, and waste production. You also want to identify energy and material use, so you're tracking the resources used in construction, operation, and disposal. And that will also help in choosing sustainable materials and energy efficient technologies for whole of life considerations. So assessing the impact of acquiring, operating, maintaining, and disposing of a facility. And that in itself will help encourage the use of recyclable and low impact materials. It also supports strategic and operational decisions. So it guides our policymakers and facility managers in making environmentally responsible choices and help to determine the best timing for upgrades and replacements, and optimizing the equipment life cycle. So it provides data-driven insight into when to replace or upgrade equipment for maximum efficiency. Sustainability isn't just a trend, it's a necessity. By implementing the life cycle assessments, we can create facilities that are environmentally responsible, cost-effective, and built for the future. As we discussed in the previous slide, life cycle assessment is an essential tool for evaluating the environmental impact of a facility through its entire lifespan. It consists of multiple stages, each focusing on different sustainability factors. The first stage is the pre-design stage, so you're defining the environmental goals of the project. and establishing sustainability targets such as energy efficiency, water conservation, and waste reduction, identifying potential environmental risks, and plan mitigation strategies. For example, setting a goal to achieve LEED certification or carbon neutrality for the building. The second stage is the schematic design stage. Here you're making critical choices regarding the building materials and construction methods, and you're prioritizing low impact, sustainable materials such as recycled steel, bamboo, and low VOC paints. Evaluating structural efficiency to minimize material waste and energy consumption. So, for example, opting for sustainably sourced wood or high-performance insulation to reduce long-term energy use. And the third stage is the design development stage. Here, you're making systems design decisions, such as including HVAC, lighting, and water systems. And you're selecting energy-efficient technologies like solar panels, LED lighting, and water-saving fixtures, and optimizing the building's orientation and insulation to enhance natural lighting and ventilation. For example, installing geothermal heating to reduce reliance on fossil fuels. So the pre-design stage focuses on setting environmental goals. The schematic design stage involves selecting sustainable materials and construction methods, and the design development stage is emphasizing energy efficient systems and long-term sustainability. So in conclusion, effective facility design is crucial for optimizing functionality, sustainability, and cost efficiency. The level of architect involvement in planning and designing the facility is critical, but collaboration with administrators and specialized consultants ensures the best outcomes. Understanding the life cycle cost analysis helps organizations anticipate the total cost of ownership, including construction, maintenance, and operational expenses, while similarly, the life cycle assessments evaluate a facility's environmental impact, guiding strategic decisions on materials, energy efficiency, and long-term sustainability. By integrating these principles, facilities can achieve higher efficiency, lower costs, and a reduced environmental footprint over their lifetime. And that is all that I have for you today. I look forward to talking with you again in part 2. We'll be breaking this down a little bit more and looking at more of the spaces, specific spaces. All right, you guys have a great day. Talk to you soon.